Okay, so I guess the stream is live. Let's just check if we are audible and everything is working fine. Yeah, yeah, yeah. So, good evening, everyone, and welcome and thank you for joining us today. Now, I know most of you all in this room know who we are talking about. He is no stranger here. But on a formal note of introduction, it's only right that we properly give him his flowers for the incredible moves he has been making. So, you meet Akash Kundu, or what we say Akash Da. He recently graduated with his computer science degree, but even while finishing up his undergrad, his research track record looked like that of a second industry veteran. He is currently the Cooperative AI Research Fellow at AI Safety South Africa, and he have just flew back from Cape Town, right, Akashta?
Mm, Yeah,
Okay.
that's correct.
So about his works, Akashda will brief you about his works on his own. That would be the best, and I won't make this session boring by doing so. But what makes his story so inspiring is that he built his entire trajectory before even graduating. So he didn't wait for a formal permission slip or years of post grad experience to start publishing his world class research, and that's why we have him today on today's session, and he will guide us on the talk that is titled "You Do Not Need Permissions: How to Do Research and Get Started Up as an Upgrad." So he's going to break down the playbook of tackling open-minded problems and building an impactful research path on your own terms. So without further ado, let's give a huge round of applause if we can from our own places and welcome Akashta.
Thank you so much, Ayushman. This means a lot. And yeah, I'm super happy to be here. So let me know if you can see my screen first. Okay, I can't see you. Just give me a second. Yeah. Is my screen visible, Ayushman? Uh, Hello.
No, no, no. Your screen is invisible currently.
Okay.
Just wait for a few minutes. I will contact you.
Okay. Sure, sure, sure.
Akashta, by then you can brief the crowd on what all things you are on, and
Yeah, sure. No,
the screen is now
I'll get to
visible, I think.
this. I'll get to this during this talk itself. So yeah, hello everyone. I'm Akash, and my talk is essentially to tell you that you don't need permission. So this is something that most people think they need before you can do research. For example, you need a lab, you need a PhD, you need a professor's blessing, you need better grades, and a lot more math. I had none of these 3 years ago. None of a lab, a PhD, a professor's blessing. I have decent grades, but it's not like the greatest possible grades that you can expect. So 3 years ago, I was sitting possibly where you are right now. I had no lab, research group, no publications, no idea how any of it worked, and I was just trying to get in. So fast forward to now, I have papers at ICLR and NeurIPS. So in case you don't know, the these are amongst the top three machine learning and AI conferences in the world right now. I have 275 citations and an H index of 5. I would explain what these words mean in a second. And I have done multiple research fellowships. And by National AI Safety Program, I mean I have worked with the Singapore government to work on the first multilingual and multicultural red teaming challenge that they organized for the Asia Pacific region. And I was the first author for that. And I have also just flew back from Cape Town, as Ayushman said, continuing working on a research fellowship in Cape Town, which is on cooperative AI, and I'm currently in its extension phase, where I'm working on the same problems just remotely. So I'm not telling any of this to impress you. I'm telling you that the gap between these two columns is just 3 years, and none of it started with permission. So, the first question that you might have is, why do research at all? So, here's what I think: engineering applies what is already known, and research decides what becomes known. So, for example, an engineer is going to build the thing that has already worked and has been brought into the field, and they design systems that get out in the real world. But what to build is decided by the researcher, who work out what is worth building and whether it would work at all before they put it out in production. So that is the difference. But now, since you knew about the pros, let's learn about the cons for a second. Or rather, I would still get to the pros, but let's go to the cons first. So it is very slow, it is painfully slow. A single paper takes like 6 months to a year. It is very uncertain. You don't even know if your idea is even right, if it makes sense, what would the reviewer say, if it would get accepted, and if it is even worth pursuing. And in a lot of cases, you don't have any way to understand whether it's going to work before you have spent a considerable amount of time on your idea. So most things you will try is not going to work out, and trust me, that is the normal state. And again, at the median, I'm talking about median here. Don't google the research scientist salaries at DeepMind or Anthropic, but at the median, it pays less than a software engineering job. And in most cases, there is no manager telling you whether you did well. Yeah. So if someone sells you research on the salary, they are selling you the tail, which is, see, look at how much people are making at OpenAI or Anthropic. But that is not the truth. You need to look at the median. And you have to understand that if you are choosing research, it's not for the money. So what should you do, like, if you want to do research even after knowing that it does not pay well? You would like to do it because you want to work on questions nobody has an answer to yet, which I think is very cool, because the things I think about hasn't been thought of before me, and if I didn't put that idea out in the world, no one else would know about it. And you get to decide what gets built instead of just building it. You might be a research scientist plus engineer who also builds it, but in most cases you are on the deciding what to build side. You also find unanswered versions of a problem more interesting than the solved one. So if you're thinking that, let's say you have an answer that, hey, this is going to work, can you implement this, that is like a solved problem. But if you are interested in figuring out would it even work out, and if that is what drives your curiosity, I think research is for you. And another thing, you are willing to be wrong in public repeatedly, because oh, is there anything? Okay, no. You are willing to be wrong in public repeatedly. Like, it's very highly likely that what you are working on won't be the best idea, and reviewers would like bash you for saying something that they do not agree with, and you still have to put your work out in the public and let the negative feedback get back to you. However, it is very rewarding, because once it works out, people value you as the person, oh, this is the guy who made this. And understand that the questions in this field need answering in the next few years by whoever shows up, and you can be the person who showed up to answer these questions. So what is research actually? So it is not a bigger version of your final year project. uh, it's not about implementing a known thing, it's not about using a new library or a literature summary, although related works is very important. You need to know what has happened in the field if you are going to do that. It is about finding one specific question nobody has answered, and then finding out ways to answer it. So here's like the thing: before this paper nobody knew X, now we do. And if you can't fill that in, you don't have a paper yet. Yeah, it's as simple as that. And it's not very simple to like just say nobody knew X and just defining it. You would also have to prove that what you are thinking makes sense and is valid statistically. But that's a different part. But mostly it's about introducing an idea that doesn't exist yet, and you are the one to bring it to the world. So here's an example from one of my previous projects. So I worked on something called dark patterns, and I want to ask if any of you know about dark patterns in websites. Let me know in the chat. Uh, can I see the comments? Yeah, I think there are a lot of people. Yeah. Hello, everyone. Sorry, I couldn't see any of your messages before. But yeah, if any of you know what dark patterns in websites are, that would be great. If not, I'll just talk about it. Iconic curtain behind. Hmm. Could you like define it a bit more? Oh, hey Shayambar, by the way. I did not see your name. Oh, Mohit is also here. Nice. Cool. Thanks everyone for being here. Okay, I guess I'll get to it myself. Okay, he means beside you. Okay. I okay, I'll get to this. I'm sorry. So dark patterns are essentially, let's, oh, you mean the curtain behind me? Ah, okay, I did not get that. Yeah, it's pretty iconic. Yeah, so if you have seen my previous videos, it's always the same curtain. Anyway, sorry, getting sidetracked. The point is, dark patterns are essentially like, have you ever went to a website and like, let's say you are using Zepto or Blinkit, like there are so many hidden charges that you don't even know when you are trying to purchase something, and it makes the value much higher than you initially expected. Or maybe let's say you go to a website and it is designed in such a way that you are bound, or like they make you feel that you should purchase their product right now. Or maybe let's say an offer, like this offer expires in like 10 minutes, so if you don't purchase anything in 10 minutes, it's going to expire and you would never get the offer again. So have you seen this? I think this is quite common, and this feature is known as a dark pattern, where there are designers of these websites who are manipulating your autonomy by showing things that they want you to do, even if that means it's uh, it's working against you. So websites have used this for years. A button that makes you spend, the cancel button, the cancel subscription button on a gym membership that you can never find, and these are known as dark patterns. Now, the question we asked was, okay, cool, this exists in website design. Does this same thing exist in large language models like, let's say, ChatGPT or Gemini or Claude? And this is like something that nobody had measured before us. There was no benchmark, no data set, no number to tell you if it did exist. And so we built one. That is essentially what we did. We found the thing that nobody had measured and then figured out a way to measure it. Now there are like ways you can measure things better, like how do you test that what you're measuring is valid? That these are different questions. That is not something you need to worry about at the moment. But at the current stage, what I'm trying to explain here is that there are so many ideas that exist in other areas of other fields, maybe in sociology, psychology, even UX design. This is from UX design that we brought to LLMs. So I think there are a lot of like things which are very abundant, but we don't see them as we aren't looking. So I would say find an idea that allows you to measure something that hasn't been done before. So what happened to this paper? So it was accepted at ICLR. It was selected as an oral. So in case you don't know, there are like three tiers. First is a poster, then there's a spotlight, which is the top 5% papers, and then there's an oral, which is like the top 1% to 2% papers. So it was selected as the top 1 to 2% papers, and it is extremely rare for an undergrad to have an ICLR oral. Like, I'm not saying this to brag, but it normally happens once in a year. But It did happen because it was a question that nobody asked before us, and they realized that it is a very important thing to measure. It has also been cited in the International AI Safety Report by Joshua Bengio, if you know his name. So, this is how far my work has reached, and I'm really grateful. But most of it happened because we thought of an idea that is new. It's very easy to like just tweak an ML model to get slightly better accuracy and think that is a paper. But what I would ask you to do is go a bit deeper, think about an idea that no one has thought of before, and then figure out a way to do it. So now the question is, how does it even work? How would you get your paper accepted? What happens in the conference phase? And so on. So, in computer science, conferences are the main venue. In other fields, journals are the best thing to target, and reviews take a year or more, and submissions are rolling. But in computer science, conferences are the destination. There are hard deadlines, a few per year, and they are fast, like not as fast because it still takes 6 to 9 months to get a paper, but it's not years. And it's peer reviewed and archival. What do I mean by peer reviewed? It is like people who are submitting their papers are also reviewers. So you are getting feedback from other researchers who read your paper, engage with it, and decide how it feels. And the field moves so fast that the publishing system is moving really fast right now. So journals cannot like make way because journals take like a year or more, and in most cases you have like 3 to 6 months before the next model drops. At the moment you don't even have like 6 months, every model is dropping in like 2 months. So things are moving very fast, and you need something else to do. So, what happens after you write it? So, after you finish writing a paper, there is a fixed date, then a submission goes in, anonymized. By anonymized, it means your uh, whole like identity of who you are, what your credentials are anonymized so that there is no bias for the reviewer. Now you might think this is a bad idea, but trust me, it is honestly a great thing, because if your submissions are anonymized, there's no chance for anyone to know that you're an undergrad. I have had like emails where people said, "Dear Dr. Akash Kundu," and I have no doctorate. I don't even have a master's, because people have no idea that I don't have a PhD. And that is the fun part of it. No one is going to reject you, and that means there's no bias that is working against you. If your paper is good, you would make it work. Then what happens is there is a review phase where 3 or 4 anonymous reviewers code it and critique it. You don't know who they are, and that is because it wants you to remove the bias. And then there is a rebuttal phase where after they give you the reviews, you have to reply to their concerns, and you have to prove them that your paper is worth accepting. And after you do this, they decide whether to accept or reject your paper. Most papers are rejected. And then there is a camera ready version where you put your actual name and affiliations, and then you present it at the conference. So a few things that you need to keep in mind: strangers are reading your work anonymously, and these reviewers don't know who you are, and they give you a score, and an area chair reads all of it and then decides whether they should accept your paper. I told you that there are 3 tiers: posters, spotlights, and oral. And reviewers in most cases are unpaid volunteers doing this on top of their own work and research. So quality varies enormously. A lot of reviews aren't great, and a bad review does not mean you haven't done good research. Sometimes it just means the reviewer skimmed through your paper. So yeah, that's something you need to remember. Just because you got a bad review does not mean the paper mm, didn't have a lot of value. Maybe the reviewer skimmed it, or maybe there were concerns that needed to be handled. But in any case, you should still submit, because once you get reviews, you have an idea on what sort of things a reviewer is looking for, and then fix that to get yourself accepted. So I'll get to a few numbers that you need to understand. So I was talking about citations. A citation is essentially, how many of you do know what a citation means? I'll give a second. Oh, Avik, you asked me as a mechanical, can you learn about this only for CSE? This is not only for CSE, this is how you do research. And in most cases, if you are in mechanical engineering, you would probably focus on, let's say, journals rather than, uh, let's say, uh, the conferences part, and journals might be more prestigious. However, I would still say there's some value on how to write a paper, and that concept transfers to any field that exists. But I would still say that my field and domain is mostly towards machine learning. So if you do some sort of ML applied mechanical, then probably. Otherwise, I'm not sure if it applies. But I would still try my best to give you general feedback. Cool. Okay. So I'll get back to citations. So it's basically, one citation means there's another paper. So whenever you are writing a paper, you have to have something known as a literature review, where you write exactly uh, which papers you have read and what you found there that allowed you to build your work. And whenever you are referencing a paper, you are citing them, which means they are getting one value increase, like they are saying that, hey, this is a paper who used our paper in their research. And there's something called H index, which is, let's say you have H papers that have at least 8 citations. So for example, mine is 5, which means there are 5 papers of mine that have at least 5 citations, and I have around 275 citations at the moment. Here's something useful. So don't chase these numbers. Your work was good or not cannot be measured by how many citations you get. I know a lot of great papers that have like 10 or 20 citations. But I do think what's more important is whether your work will matter in 10 years. And it doesn't matter how many citations you're getting. If someone is like citing your work like 5 years down the future, it means it did work out. So don't chase the quantity of citations, but rather the quality and the time for which your work is relevant. So, a few things that nobody tells undergrads. There is something called Archive. It's a free public preprint server where you can upload your papers, and it's instant and permanent, and there's no gatekeeper, no fee, no permission. And this is how most ML work is actually read, by the way. Like, even the paper that I would be submitting to conference, we would be publishing a preprint on Archive. Most of my papers are on Archive, and that is what we use. So I want you to know that Archive is honestly a great thing to look into if you're publishing. So you don't even need permission to wait for someone to accept your paper. You can just put out a preprint. It won't be the greatest when you are starting out, and uh, you develop something called research taste when you are getting further and further. But what's more important is that you start somewhere, because once you start, you have better ideas the next time around, and when you get reviews, you are exposed to things that you didn't already know. And there's something also called workshops. So let's say I was talking about ICLR and NeurIPS. My papers that I was talking about were in the main conference, and there's something known as a workshop that happens in the big conferences like ICLR and NeurIPS. And they have much higher acceptance rates, like 60%, 50%, 70% at times. And you get real feedback from real researchers. The only con, I don't think it's a con, but it's non-archival in most cases. So your paper won't be published, as people say that, hey, my paper is published. But you can, that means you can submit a full paper to another main conference, because once a paper is published, you cannot do anything. But if you do have a workshop paper, that also means you did go through the peer review process and you got yourself accepted. and it's the best place to get your first paper. And here's the thing: aim at a workshop first. First of all, we get something on our archive, and then aim for a workshop first. And almost nobody's first paper goes straight to a main conference. There is actually like a workshop at New Reps this year called New in ML, which essentially is targeting people who are new in machine learning to submit papers. And that I felt was really cool that they were focusing on this instead. So yeah, workshops are a lot more accepting, and I think it's a great way to get started. So how to actually start? Let's say you need concrete moves. So there is a research sprint that is starting in 2 weeks. So it's the Digital Minds Research Sprint. It's about designing and running experiments to understand whether frontier models have real preferences and what their self reports are actually worth. And this is happening very soon, and you can sign up for this. And there's this QR code that would allow you to go there, and they say something on the website which is no prior background in the field is required, and that sentence is on their page and they mean it. And trust me, the first time I got started with research, I applied for a hackathon. The sprint is essentially a hackathon, but instead of creating an app, you write a research report, and if your work is liked by them, you are called into the lab fellowship. Apart Research does that, and I was accepted into Apart Research's lab fellowship, after which I worked on the paper which got accepted as an ICLR oral from Apart. And that is how like it has worked out for me. So yeah, I think it is very important that you take this seriously, because I think this is the best entry point for people. So on Friday, the problem statement drops. There are 6 tracks. You pick one team and do it. They have a Discord server, so you can ask people and talk to them and go from there. And it's pretty much a similar concept. You can talk to people abroad, or you could also take someone from your college and do it. It's fine. And on Saturday, you decide one question and then run experiments. Small and finished beats big and broken projects, by the way. And you submit a short research report, as I've said. You can give a code or a demo video, but they're optional. And real researchers read and score every submission. There is a chance that I might be a judge. That doesn't mean I would give any of you preferences if any of you submit, but I might judge this round. I'm not sure. Depends on my mm, like availability, but I'll probably do it. But once I do, I think uh, I would be reading your work, or someone like me would be reading your work. So I think it's a great way to get feedback without having confidence. And it's just 3 days of work, then a week to get feedback, which I think is amazing for someone who's just starting out. And top teams get applied to the fellowship. uh, it's 3 to 6 months funded, not in the sense that you get a stipend, but funded in the sense of you get funding to perform research, like API credits and compute, and also mentorship from senior researchers, and also publication support, and maybe like uh, travel budgets if you are submitting or presenting your work at a conference, which I think is all pretty cool. And the last line is exactly what I walked through. It's not a side quest, it is the entry point for a lot of people. So here's what you can start now. Look at a paper that you like or something that you have read about. If you are using, let's say, random forest, I don't know what you're using, or if you have learned about, let's say, LoRa, or you have heard of it. When you are fine tuning LLMs, I know a lot of people who fine tune LLMs, and you use something called LoRa. So you can just look at the paper and maybe ask Claude to tell you how to understand the paper, which parts are mathematical, what you can use LLMs to help you. I'm not asking you to completely depend on them, but use them to find what is possible, and then try to rebuild its main result. And you will essentially learn a lot more in 2 weeks than probably a semester in coursework. And you will find things that don't reproduce, which is honestly a great result. Like, you would find things that are not matching what they are saying, and that proves that the results are sometimes different from what they are stated as. And then you can put it on GitHub and with a clear readme, and you say what you found. And now you have evidence. And once you have evidence, you are taken more seriously. If you tell people that, hey, I want to work with you, no one cares. But if you show them that, hey, I've built this and now I want to work with you, people might care. So now that I've talked about papers, I also want to talk about how to read a paper without, let's say, drowning. You start with reading the title and the abstract and the figures and the conclusion, and that's when you decide. You don't read the main body. I know a lot of people who start reading a paper end to end. That is not how you do it. You just read the abstract. If you like the abstract, you look at the figures and then the conclusion and see if it matters to you. If you like it, you read the structure. By structure, I mean you look at the methodology, you look at the results, and see if it makes sense. You don't have to look at the proofs. You have to understand what they did. And once you understand, like, what that this is a paper worth investing your time in, you read every detail, every equation. So here's the thing, like, people think it takes hours to read a paper. It doesn't. It takes 5 minutes to decide if a paper is worth reading. It takes 30 minutes to figure out if the paper is something that you would want to work on. But it does take hours if you want to build their work or improve what they have already done. So yeah, never read a paper from top to bottom. No one does that in the field. And there's something that I have done which has worked for me, and I want you to try it out, which is cold emailing. But it only works if you attach evidence. So you can say, I am deeply passionate about your work and would love the opportunity to contribute to your lab. But what works instead is saying, I reproduced figure 3 of your paper. I got the same trend, but it breaks below 1 billion parameters. Here is the plot and the code. Is this expected? Or maybe you say, I did try out this idea and just tweak things a bit, and that this did not work. Like, very similar to this. And once you do that, there's a very high probability that the uh, professor is going to reply and care about you, because you have put in considerable amount of effort to get noticed. And evidence is key here. So yeah, be short, be specific, have something attached, and have a question they can answer in 2 lines. Professors are in most cases very busy, so this is a great way to, like, give them a valid thing to answer back to. So when I talked about how I started, nothing has started with a fellowship. It started with a hackathon that I just showed you. Then it led to the research fellowship. Then it became an ICLR oral, which led to everything else on the first slide. So fellowships are the best thing in this field, but you do not get one straight out of the bag. And you don't have to always get into a fellowship. You could also try getting research internships at universities, and that is also a kind of, let's say, uh, experience that you might have. You can show professors that, hey, I have tried reproducing your work, can I get a chance to contribute? And once you have evidence, you can use that research project that you worked on with the professor during the internship to take it uh, to other people in this fellowship so that you get one. And a sprint is some level of way to get some credibility, and the research experience comes either through internships or, as I said, evidence. So every step here is essentially small enough to start on a weekend, and the chain builds up on its own over time. And it is a self-fulfilling prophecy. Your first opportunity leads to the next opportunity, and the next opportunity leads to a bigger next opportunity. So keep that in mind. Don't try to target like an ICLR main conference paper on the first day. Try doing well in the hackathon. So where this actually leads, like I told you about the cons of research, I need to tell you about the pros. And trust me, it is not only becoming professors. So four things a research profile unlocks. You can get into a PhD often without a master's. So for example, I'm currently applying to PhDs. I'm not applying to masters. I have my reasons, and you can ask me later why. But You can do this only if you have very cool research publications, and that allows you to like skip a degree, which I think is honestly pretty cool. And that I think is amazing because you can become a doctor earlier than your medical friend becomes a doctor. I know that sounds crazy, but yeah. And you can become a research scientist at frontier labs and industry research groups, and that is a very fulfilling position because you get to decide the questions that are thought of for years. And you get research fellowships like the one I did in Cape Town. It could be remote or it could be in person, and I got to travel to Cape Town. And there are other fellowships out there. There's one in Singapore, there are ones in UK, in the US, in Canada, and these fellowships are mostly funded, and they're also funding your travel and accommodation, so you don't have to worry about anything. But these things happen later once you have a lot of research evidence and experience. But yeah, this is also a pathway, and I know people who really enjoy and find it fulfilling to visit countries and also enjoy the research they are doing with a professor and a mentor and a deadline, something that you cannot get outside. And there is another route, which is academia, which is the professor route. It is slower, but you have a lot more freedom to do what you want. If you're in a research scientist or as a research scientist in an organization, you don't have the freedom because you have to work what your organization needs. In academia, you can have a lot more freedom. So that is pretty much most of what I wanted to cover. But lastly, I want to talk about how do you write a paper itself, because you might wonder that, hey, you said so many things, but how do you even write a paper? And I know nowhere to start. So the way you do it is, nobody writes a paper from top to bottom, just the way you don't read a paper from top to bottom. You do it the exact same way you read. You cannot write the introduction without knowing what you found, and the title is the last thing you write, not the first. So you start with your results, which happens after you run some experiments. You create the figures based on the results. You write the methods which led to the results and the figures in the first place. Then you write the introduction, then you write the abstract, then you write the title. But you can also shift this, like you can start with the methods and then the results and figures. But the reason I'm talking about results and figures first is because it's likely that your first results may not be the best thing, so your methods would change. But if you are going from a result driven approach, you are choosing the right pathway to follow, and your methods would be correct. You don't know if they are correct until you have that level of feedback from, let's say, peers or mentors or professors. But this is a way to look at, honestly. And here's something: you cannot state your own contribution. Sorry, here's something that I want you to know. If you cannot state your contribution in like one sentence, you don't have a paper yet, you have a project. So this is something very important. Whenever someone asks you what did you do in a paper, you need to explain it in a single sentence. If you cannot do it, it's not correct. And I want you to keep that in mind even for the research sprint. Like focus on the results, figures, and methods, and then write intro, abstract, and title. Oh, and there's something also which is very important, which is the related work section, where you have to explain what are the uh, kinds of papers that you've read that has made you decide which experiments to run, that led to the results. So I think that is something you should target. And here's something: rejection is the normal state of this job. Most top conferences reject three-fourths of the papers they receive, and everyone in this field has papers that were rejected, sometimes repeatedly. I have multiple rejected papers. And a rejection is information about one submission and read by three tired people on one day. So it doesn't always reflect how good your paper is at times. Sometimes you just were unlucky. And the only people who stop getting rejected are the ones who stop submitting. So don't be afraid of rejection. Rather, understand what the feedback is saying, implement that, get a better paper, and then publish it. So yeah, you don't need permission, you need one finished thing. So sign up for the sprint, pick one paper and reproduce a figure, post the code publicly, and send one email to a researcher whose work you actually read with the result attached. And you could also talk to professors and ask for help and support. And I know that professors even at our university would help. You need to get started first because you need evidence, and once you have the evidence you can target the next thing. As I said, it's a self-fulfilling prophecy. Your first opportunity leads to the next opportunity. Don't wait for getting the best opportunity on the first day. So yeah, let's talk about questions now. You can ask me. So here's something. If you want to know about me, there's my website. So everything I've done is here, and there's like an Instagram that I follow. I think LinkedIn is overrated. Text me on Instagram. And yeah, if you prefer being a bit more formal, you can send a cold email to me as well. And I really enjoy getting these. So write a good email, and I promise you I'll read it and give you a solid reply. So yeah, ask me anything, including the things you think are too basic to ask. And yeah, I'll give the rest of the time for questions. That's it. Okay, I see a few questions now. So how much AI generated works get accepted in white paper? Okay, uh, this is a very interesting question because I would not say AI generated, but a lot of work that is getting accepted in the field is AI assisted. So even I have used LLMs to help me write the code after I have figured out the idea. So as I said, a researcher's goal is not always writing the best possible code. That's an engineer's role. The researcher's goal is to figure out what is the right question, what is the right idea, and then figuring out how to implement it. And you could have an LLM help you design and code that aspect of your project, and that is where LLMs come in. But uh, if you are trying to make the LLM write the paper itself, you are not doing justice to how the researcher does their work. So you need to ensure that your uh, paper is LLM assisted, at least in code. That is fine, but you need to ensure that you are writing it and you are the person who thought of the idea. Don't use LLMs to generate ideas. That's not going to work. You have to figure out the idea yourself and go by there. Now there is a problem that maybe ideas that you are thinking of are, let's say, not the best when you're starting out. It is a research, uh, your research taste gets better with time. So you have to uh, wait and make bad decisions and write bad papers before you start writing good papers based on feedback. So I would say write papers, get feedback by posting it in public. Archive is a good way, or maybe getting it in a workshop that gives you feedback is a great place to start. And yeah, so that's pretty much it. And someone said you said about running experiments. Could you elucidate with an example? Sure. So what I mean by experiments is, let's say you want to prove that. So for example, the paper that I have been working on had this situation where I was trying to prove mechanisms that increase cooperation between LLMs. So, for example, humans are interesting negotiators. So, for example, if you say someone that, hey, I want to buy this, and they quote a number that you don't like, you are just going to walk away if they don't give you the value at the price that you're asking for. And the problem with that is, if the person stops you and agrees to give you at that price, they are taking a hit. And let's say there's a possibility where you pay what they asked for without asking for a bargain, they are making a profit without, with you taking a hit on the value of the product. But an interesting thing that happens with LLMs is that both of them want the transaction to happen. Humans are very happy to just run away from a transaction if they don't like the price. LLMs would want the transaction to happen and would pay the fair price. So let's say something is worth, let's say, 100 rupees. A human would be like, 30 rupees se zyada nahi dunga. But like, and you try to walk away. But an LLM would say, I offer 60, and then the other LLM says, sure, that sounds fair, and they accept it. So in this way, both of them are cooperating. And there are ways where we try to figure out how do you make them negotiate better, how do you increase their cooperation, how do you help them achieve mutually beneficial outcomes. And these are the things that we work on, and as you see here, these are all high level ideas. So I have to think what are some questions that I could answer that could help me understand if one of them is taking a hit, or if one of them is benefiting more than the other, what would be a mutually beneficial outcome, and how can I test it. And these are all experiments. I have to design it and then get the answer. And you always need something known as a hypothesis, where you essentially think about what is going to happen before you run the experiment and check whether it like agrees to what you initially thought. So don't run an experiment blindly. Think what is going to happen before the experiment, then see if it changes your expectation. If it does, that is a surprising result. If it doesn't, that is still a result that you were expecting, so that's good. Yeah. So for how to get funded for registration fees for workshops of A-star conferences if our paper gets accepted. That is an amazing question. And I'm glad you understand what is an A-star conference. So you are already ahead of most people. So how do you get funded for registration fees? So here's the thing. If you are applying for, let's say, uh, conferences in general in India, they charge like 9,000 or 10,000 rupees. And virtual presentations for students, I'm not asking here to like uh, go for like conferences. The virtual presentation for workshops are like $50 to like $100 in most cases, and $100 is like 8,000 or 9,000, so it's roughly the same amount of value. And you could talk to your university, maybe asking if they can fund this because this is a great opportunity, or there are funds and grants that you can apply to once you have your paper accepted there. But it isn't as exorbitant as you expect. It gets very difficult when you are going in person in the main conference, but otherwise even workshops in person cost like 125 or $200, whereas the virtual presentations are like 50 to $100. And if you are like uh, seeking for grants to the star conference, at times this also gets waived. So yeah, that is something. So for someone starting cold, how should it be? Like you talked about reading papers, from where to get to those? Can I use LLMs to help me in that phase? Then the void between reading and writing also. Okay, so there's something which I really enjoy. So I think there would be one paper at least that you know about. I don't want you to find like tens of papers. Find one paper, and I'll share a screen. So let's say uh, I'll just show you a new screen. So there is a website that I really enjoy, and it's known as Connected Papers. A funny incident: if you are using Connected Papers, you should actually use incognito. And the reason for that is, if you use incognito, you can actually use it forever for free. It's an infinite research glitch. Anyway, but I'm not using incognito for now. So what you do here is, let's say I search my paper here. It should arrive. Yeah. So this is my paper. So let's say you know about my paper, Dark Bench, and you want to learn what the field is, what papers exist, and you click on this. And what Connected Papers does is essentially creates this graph where it shows you what papers exist. So this is where my paper is. It shows you what other papers exist in the field. So there's this paper, there's this another paper, and once you see this, you can get an idea of all the papers that exist in the field. And I think that is a great way to move forward. So this allows you to find papers, and once you find these papers, you can use this to uh, start reading. And as I said, follow the technique. Like take 5 minutes, read the title, abstract, and maybe the figures and conclusion, and then the 30 minutes going a slightly deeper dive in the methods. And after you like it, go for hours. But at this level, I would ask you to just take 5 minutes to 30 minutes on a paper max. I don't think you would be able to do it in 30 minutes at the moment, but you can take an hour and still get things done. So this is how I find papers, and use incognito for connected papers, because you get like 2 to 3 free drafts. And like if you use incognito, you can just close the tab and you would get like 2 free drafts again. And every time you exhaust your 2 graphs, you close the tab and open it again, and you have infinite number of 2 tabs, two graphs. Yeah. How many hours should one dedicate per week, at least, in order to balance academics with research paperwork? And could you elucidate on the importance of language, literature, grammar in writing a paper? Okay. uh Tough question, honestly. I genuinely don't know, and I'm like a bad example to ask this. Miss Reshma would know. I probably wasn't like the person who attended classes quite often, so I'm not the greatest example here. But I would still say that in a lot of cases, your uh, like academics are important. So let's say it's a machine learning class, you shouldn't skip them. But then there are classes like, say, ethics, and you need to pass. But it's better if you focus your time on research, and you know how to prioritize which subjects and which to like uh, take a step back in, which you can handle. So yeah, that is something you should be. But I don't think there is this fixed number of hours that you put in. It's rather finding an idea and see where your curiosity leads you. I don't try to think how many hours it would take. I'm trying to think, okay, this is an idea and I want to get to the answer. How long would it take me to get to the answer? And I'll find ways to get that. So yeah, it doesn't matter how many hours it takes, and that is the fun part of my job. Like if you asked me how many hours I worked in Cape Town, there were days when I worked for like 3 hours. There were days when I worked for 14 hours. So it totally depends on what the work needs, how many experiments need to be done, what results am I searching for, and that's how it goes. So it could be very taxing at times and very chill at times as well. Okay. Okay. Oh, this is by Anusmriti. I'm sorry, I did not see you. Hi. And about literature, language, grammar of writing a paper, I think it's fine if you are able to explain what you're doing. But what's more important is being able to see things concisely, because pages are always short. No one says that I wish I had like less pages. If you think you need less pages, that probably means that you didn't do enough work. In most cases, people think they are going for uh, mm, in most cases people think they have like uh, I lost the plot. Yeah, in most cases people think that they are lacking pages, so you have to be very concise. If you can remove a word from a particular sentence, remove it, because you need to be as precise and use every word should have a lot of importance. If you don't need a word, don't say it. What are the current topics of research that you are most interested about and are working on, and how to get started with AI safety, and what are the current frontier research going on in this field? Amazing question. So I do work in AI safety, and I work in a field called cooperative AI. So if you are going for AI safety and want to know what is happening in the field, I want you to look at this. So I need to connect my YouTube, just a second, so that I can comment. Just give me a second and I will comment. Yeah. So here's like this website called aisafety.com, where you can check out. Oh, okay. They are not allowing me to post it, but it's aisafety.com that you should go to, and you should be able to find uh, the relevant fields and ideas that exist. And how to get started with AI safety, I would ask you to look into the research sprint, as that is very AI safety adjacent. And then I would want you to look into uh, let's say fellowships like Spar, there's Mars. I think I would need another session take it. Yeah, I think you should ask me this like personally. I did give you my email, my like website and Instagram, so you could DM me anywhere and I'll give a longer answer, because I don't think it's something that I could take in this call. What is the package of it? By package, do you mean like the salary, or what? What exactly do you mean by package? Or yeah, I want to specifically understand your question. Heritage package? That is not like a question that is like similar to what I did in my talk at all. So yeah, I think you could ask seniors and others, but yeah, uh, I'll not take that question, I'm sorry. So yeah, I think we are on time. So yeah, is there anyone here? Ayushman? Oh, Rahul. Hey.
So thank you भैया. I guess अब time हो गया है. I'm ending the stream now.
Sure. Yeah, thank you everyone, it was really nice, and do reach out if you. Bye.